Okay, so now let's get started using SQL with our Iceberg tables. So the beauty is that Dremio is a SQL query engine, so you can write SQL and do all sorts of fun stuff with it. And again, SQL stands for Structured Query Language. It's a declarative language for sort of essentially asking questions of your data. And typically you would do that to like just say, hey, I want this data, I want that data. Just to kind of give you an example, if I were to go to the sample data set here and use some of the sample data that Dremio provides, what I'm going to do is I'm going to access this weather data set. And notice it's a CSV file. So typically, again, files aren't immediately queryable because it's not a database. But Dremio allows us to sit there and say, hey, I have this data file here. I'd like to promote it and treat it as a table. So I can then go in here and then make sure I set up all the stuff. So extract column names. And that should be all good. I hit save. And now notice I have this SQL that allows me to select data from that table. And I can actually start doing things like, hey, I want to select all from that table where we'll say snow. So there's a field called snow is greater than 0.0. Okay, and then we can run that query. And see now I only have versions where snow is bigger than 0.0. So all those records that had 0.0 in it are gone. Okay, so I can use Dremio to access all sorts of different types of data and query. And again, you can query data from all sorts of different places, as you can see here, that you can connect to. But because I have an Iceberg catalog, and again, many things can be used as Iceberg catalogs, such as AWS Glue, Hive, any of the object stores using the Hadoop catalog, but specifically with Nessie, or any Iceberg catalog, I can now begin using SQL. Nessie is going to give us extra features, which are those get for data features, which we'll explore more so later on. But let's actually watch this at work. So I'm going to click here, which is our SQL editor, and I'm going to create a table in our Nessie catalog. So basically, in SQL, if you notice, I'm writing in all caps. Anytime I write all caps, that's a word that belongs to the SQL query language. So if you're not familiar with SQL, just remember that. Capital letters, that means it's a word that's part of the language. If it's not all caps, then it's something that I can choose the name of. So in this case, the table, it's Nessie. I have to put the name of the catalog that I'm putting the table in, which is Nessie. That's what I called it when we set it up. And I'm going to make a table called names. Okay, so Nessie.names. Okay. Or we'll call it like people underscore names, no spaces. Okay. And then in parentheses, what we do is we put the schema of the table. So we're saying, hey, this table, what is it? What's the structure of the table? So I'm going to say, hey, this table has an ID field, which is an integer. Okay, and again, see, that's uppercase because that's a keyword. So we're saying, hey, this is a number field, a whole number. And then there's going to be a field called name, which is a varchar, which is a string, so letters. So I basically said, hey, create this table. So in my Nessie catalog, create a table called people names, and it's going to have these two fields. So I click run. Okay, and let's see that names. Oh, it's because, and again, I have to make sure I zero this out. So no context. Yep. Okay. So if I run that again, and what this context switcher does, just so you know in the future, notice how I'm typing Nessie.people names. What if I didn't want to have to type Nessie every time I'm referring to the Nessie catalog? What I could do is I could choose Nessie as the context, and then I could actually just take this out. I wouldn't need to write Nessie because Nessie will be implied. Okay, so I didn't realize it was a context set, but I want no context set, so I type out the whole thing. And then again, if I run the query, that's all going to work. And see, the table was created. Okay, so now if I head over to Minio and I look inside my warehouse bucket and I refresh, we can see, like, look, there's a new people names folder. And if I go inside that folder, I see a metadata folder, but I see no data folder. Why? Because we haven't added any data to the table yet. There's no data in the table. Okay, so in this case, there's only metadata. And if I go inside that metadata folder, we see that metadata.json file, as I mentioned earlier. Okay, so there's only one because only one thing has happened to the table. It was created. Okay, and then we have an Avro file with a snapshot that has no data in it. Okay, so now what happens if we change the table again? Let's actually input some data into that table. So to add data, it would be insert into. Okay, and I say, hey, I'm inserting into the table Nessie.peoplenames. Okay, notice this Dremio has autocomplete, which makes life a lot easier. And then we say value. Say, hey, what is the data that we're going to inject into that? So in this case, first, so each parentheses represents one value. So we're going to have the first record, which we'll say is me, so Alex. Then we're going to add another record, which will be okay. But basically what we do is we just keep using commas to separate each one and parentheses to separate each one. So this will be 2, and then we'll use my brother's name, Tony. Okay, and then at the end of the query, I put my semicolon. Okay, and then I can hit run, and then it's going to run that query. Okay, so you can see now it says 2 rows were inserted. So if I head over to the Minio console again and I refresh, see now I notice that there's 2 metadata.jsons because there's a new one from the transaction we just did. So again, Nessie will have been updated. So now Nessie should be pointing to this metadata.json, not this one. Okay, and that's kind of how that whole catalog works. Everyone who uses that catalog as a way to access the table will get pointed to the right metadata.json. And then here's all those metadata. So this is like a manifest. You can tell because it doesn't have the word snap in front of it. These that say snap, those are manifest lists. So those are the snapshots. And then these are the manifests. Now, if I go back to the people names folder over here, I can see that now there is a data folder. It's not called data, but if I go inside this folder, I'll find Parquet files that should have the data that we just added. Okay, so you can see, hey, as we operate on the table, it is affecting our storage system. Okay, and that storage is accessible by anybody. Okay, well, by anybody who has access to the catalog. So now I can query that table and see the data inside of it. So I can be like select star from Nessie.names. Okay. Oh, it's people names. People. Always nice to see nice, good errors that make it very clear what I did wrong. Oh, that table doesn't exist. That's right, because I didn't call it that. Okay, and just make sure, but I called it people names. And the cool thing is, if I didn't want to type out people names, okay, so let's say I don't want to type all this out, I can actually just drag it from here and just drop it right in there. Okay, and Dremio will fill it in for me, making life a bit easier. So again, a lot of little quality of life features. As you can see, I'm in dark mode, and you can switch between dark mode and light mode. Lots of really nice quality of life features here. So I can hit run. Okay, and there I can see the 2 records of the data that we just inserted into Apache to our Apache Iceberg table. So we're working with Apache Iceberg, and you can see it's an Iceberg table because you can see it's like a little purple table symbol with the Iceberg logo next to it, making it obvious that that is an Apache Iceberg table. Okay, and again, you can run all sorts of transactions. Again, you have the full CRUD functionality with Iceberg tables on your Lakehouse. So I can go update. So I can say, hey, update Nessie.names or people names. So I'm going to set the name to my full name, Alex Merced, where ID equals 1. Okay, so I'm saying, hey, find the record whose ID is 1 and set the name of that record to Alex Merced. Okay, and I hit run. Okay, and it updates, and 1 row is updated. Okay, and if I go back and I refresh, okay, if I go back to people names, see there's another folder. So every time you write data, Dremio is going to make a hashed folder. And there's a benefit to that as far as like the way, because typically it's anticipating that you might be writing to S3, which has certain throttling rules, and this kind of helps make sure that you get best performance. But you can see that like, there's 2 folders here. And so this one has like the newer data. And then again, here's the metadata, and you can start seeing the number of metadata.jsons are growing. Here's the newest one, and that would be the newest one that Nessie is going to point to. So you can see as the metadata kind of builds up, all this sort of table metadata. Okay, I can also delete data. Okay, so it's this. So I can be like delete from. Okay, Nessie.names. Or Nessie.peoplenames. where ID equals 2. So I'll delete my brother. Okay, so I hit run. Okay, awesome. And then we got that. Cool. Now that's all fun and good. So if I go back over here, again, I refresh, we'll see more metadata is being generated. Okay, now if I were to query the table right now, so if I do select star from Nessie.peoplenames, there's only going to be one record in there now because we deleted Tony. So I should only get one, right? Because it's going to, by default, it's always going to hit the newest snapshot. Okay, and generally most tools are going to default that way. Now, because we're using Nessie specifically, Nessie is going to have its own commits. And I can easily capture those commits here. So I can head over, when I'm setting in my context here, I can choose Nessie, but I can click right over here, and I can actually choose a specific commit. So I can say, hey, you know what? I want to go back to, let's go back here. Let's go back to this point in time here. So I hit apply, and see now I'm querying the data as it was during that commit. Okay, that's the context. Okay. And then I can also, I don't need this Nessie anymore because now I have the context set to Nessie. So now I can just say, hey, select star from people names, since it's going to assume Nessie.peoplenames. I click run, and see now I have both records again because I can go back and query those historical versions of the table. But the nice thing is that if there's multiple tables that are part of my query, when I set that commit on the catalog level, it lets me go back. It rewinds all the tables as the catalog was at that point in time, instead of doing it for each individual table, using the table level time travel. So that's one of the benefits of using Nessie specifically over other Iceberg catalogs. You get that nice feature, and then Dremio really integrates that functionality really nicely. Okay, so yeah, so that's like a quick tour of just like using basic SQL with an Iceberg table and just kind of seeing how it affects the file system. Hopefully you guys enjoyed that. I'll see you all in the next video.